What is up? Long time no video. Out here in the laboratory. Going back through my Frankenstein Slim heat pump controller. It's been working for months. And then I noticed when I was in there, it's kind of every once in a while it acts up. And then you see the LCD will be all scrambled and whatnot. So something, noticed on some of my boards. I used to not notice it a long time ago so much. But I've noticed it lately for past year or whatever, as I get some weird stuff going on. So I'm going to reach down here and just kind of touch with this because it's conductive. Down here on the bottom of the switch. See that? Isn't that weird? So I was kind of testing some inputs just to see which ones did it. The glare is just a plastic over on here. Let's see, I'm going to take that off. So I noticed like when I touch certain inputs, this little X-Acto knife's just perfect for being real touchy in there. You kind of see that it acts up on some of them. So it almost acts like an antenna or something. Oh, that one's one I fixed. Looks like I got that one fixed. Let me go over to this other one. Yep, see, there it goes. So I just added some capacitors across the open contacts. I'll show you what it's doing. It's so small I never hooked up the scope. I could just take a fathom. But I noticed these ones weren't causing any issues, and they're all on RB ports. And maybe it's just because this thing, the way this is wired, I don't know, it's not causing any interference. But get a lot of interference on these switches. So these right here signify these little push button switches. And they used to wire all my stuff with like a pull down resistor, for example, and then the switch would, have one leg tied to 5 volts, and when you push the button, it would change your input from a logical 0 to logical 1. But because these microprocessors have something called weak pull-ups, and they have it on port B on this processor, you could turn those on. And so what it is internal resistors from 5 volts to the input, really high resistance. So they call it weak pull-up. And the kind of cool thing is, okay, I could just put these are my inputs tied to those ports, button, plus, minus, and menu. So what is that? RB port B2, 3, and 4, right? Which these buttons right here was 3, 4, and 5, or whatever it was. 3, 4, 5. 3, 4, 5. Those are the ones that give me a lot of the problem in the software or in the configuration of the chip. It kind of does that whenever it programs the chip. It sets some things. And so you turn it on weak pull-ups. So it pulls those pins up to 5 volts. And then the thing is you don't have to add resistors on your circuit board. You just have to tie that to the input. And the other end of the open switch is tied to ground. So it's always a logical 1 for 5 volts until you ground it with the switch. So in my code, I usually have to just remember that and, recognize that the button is pressed when you push the button. So I'm not only using weak pull-ups, I'm using interrupts. And what it is, the interrupt on change goes and look and go, okay, this one switched, so it's going to do this. It just recognizes the button or whatever, or an input. It seems that with the way the circuit trace goes, and maybe with all this metal of the going across each one of these, it was like a perfect antenna, I think. And I've had this happen on a couple different circuit designs of mine. And I did try to use an extra one of these boards. Here I just remapped what the relays were, but I want to replace that board, which is the F690, the old school way. It's using parallel LCD, all that stuff where I've kind of graduated to using the serial through the I2C and the weak pull-ups, like I said, smaller processors. This is my circuit board. I designed it, just had it made for me, so it's not one of those etched ones. Sometimes, I've added a couple filters on it. But I had made this one, kind of modified it at one point, just trying to do the inputs, use this board for everything. And it turned on, but as soon as I put it in here, I was getting some random interference, and when it would sometimes just lock the processor up. I'm like, what the hell? So it's using all the same kind of setup that is. I'm like, what's going on? So I think it's just those, I think it's the trace, the length of the trace, and going across that switch, that the weak pull-ups is just actually getting a lot of stray interference, especially when you have AC power, line voltage, and 24 volts around. There's only so much you can filter out. So I just added these capacitors here. I was able to kind of touch the chip and get it to do it. Now, see, now it's not. It's staying pretty stable. I still got one I didn't fix, but I used to be able to rub my finger on here, generate some static or whatever, get that thing to act up. So I think I fixed it. So I just wanted to kind of make a quick video on that. I'm going to add one more capacitor. I have prepped right there. It's a 1 microfarad. So, as I said, I could touch this one here probably a couple times, and look at that. It's probably throwing like thousands of, you know, high and low level changes in there. And I'm pretty sure I have. Let me double check. Speak out of turn by. I know I'm using the interrupts to recognize and go see whenever the thermostat input has changed, just because that's important. So let me go double check. So check inputs. Here's where do I have my check inputs? Oh, I think they're way at the top. All these subroutines or functions, as they call it here. Thermistors and check inputs. Yeah, so I do have it monitoring. There's my Y1 input, and these are actually different combinations of changes. So it was like, oh, if this and this, then it's gonna be this, this, and this. And I do have the button here and these buttons in here. Yeah, I do have them in there. I know that I also monitor the buttons when I'm in other modes, other functions. I think like when I'm in my menu. So I must be turning off my interrupts when I'm in here, because I'm just scanning. I'm just polling, as you want to call it, for all the button presses. And if I didn't turn off the interrupts, it would not only, you know, this would do this function here, it would it would also do that. So I'm trying to remember. I think I have it. Dude, it's been like a year since I first wrote this. Somewhere like that. If not, that's weird. I'm probably getting some extra presses or something. That'd be kind of whacked. It'd be jumping from here back to the interrupt and back. Sure I don't have the interrupts turned off. I might have to look. Oh, no, I do turn them off. Look at that. See, I knew I had to have. Right here is our port B, register port B, you know, interrupt enables off. Turn off the interrupt option so I could use the buttons here. See, I told you I first wrote this program like a year ago, and I've like modified it over time. So, okay. So I'm just trying to make sure there's not a couple little glitches and mistakes. I've made a couple little differences now that it's gotten to be summertime, so it starts the fans earlier. Those brushless DC fans take a little bit of rocking and then a little bit of getting to go. So if you just start that skull compressor and starts building up the pressure faster, and that motor's IPM, inverter power module, could get the motors going, you know, it kind of creeps up on the head pressure. It would almost trip before I kind of modified it, you know, a couple months ago. But so I've added a couple things in there to make that faster. And one of the main things I did a while back that fixes if they, where was it? Yeah, if it's, this is just so it knows at start, if the pulse width modulation's at minimum, fan minimum, that's always only going to happen once when it starts the cool thing. It's, you know, and the outdoor air temperature is above 80, then it's just going to, the minimum's going to be higher. That's all that means. And then after it's above minimum, then it just skips this, you know, it's just going to go plus minus the pulse width modulation as the temperatures are too high or too low. So anyway, that's been working pretty good. I kind of increased the starting speed just a little bit more now that it's kind of getting to be over 100 out there, and kind of messing with it today. And then I thought, you know what? I noticed when I reach in here, sometimes it would just randomly do that weirdness, and it's been doing that. I tried to shield some things. It seemed like it was better, but I think it's just these traces and metals acting like a antenna, and the weak pull-up, the nature of that processor, just, that ain't gonna work when I'm doing stuff with around line voltage. I do that all the time on other stuff, which is just mostly all DC voltages and you know, just logic levels and stuff, and controlling certain things and LEDs, and I don't get the problem. But whenever I've introduced line voltage around on the board, it was picking it up. So I'm going to add that other capacitor, and then after I do that, I'm going to go in here and touch this. You know, it should stop doing that, which is this, I think this trace right. It's this trace right here. See, it kind of does the same thing if I keep just tapping it. So get that capacitor on there. Okay, just added the third capacitor there. You might have made it a little ugly, but I mean, who cares? That's right there. I didn't. These are all surface soldered on the top. They're not through a hole like these are, so I couldn't hide the capacitors on the bottom. So, no big deal. So now should be. I'm going to touch here. I don't get any of that nonsense. I'm going to touch here, this one right here. No, so I used to be able to just move my finger around here and get that stuff. So for some reason, we got the other port bit registers going to these 3 optical isolators as inputs, right? And these are just open across, like a diode or whatever. I don't know if they're acting as what. Oh, I know why. I was gonna say, why is it fixed? It's because those go to AC to DC from 24 volts, and there's capacitors. Those are 22 microfarad surface mounts. I forgot to add them on my circuit, but I've always been able to just solder them across those 2 pins, just the same. So that's why those don't act up. Yeah, I think that was one clue. I kind of was testing all those, and I was noticing just these 3 was doing it. So I think I got this board ready to go. Let's see, my temperature's pegged out on 2 of these things. Let's see, one of those should have went to some normal range. I'm just using a fixed 10K, so that's why one's at 77 degrees. And I got my outdoor air liquid line. So, oops, let's knock that out. That's real good. And here's just the layout. Not used pins, but it was these 3. This one on pin 11, 14, and 15. Those 3, which is RB345. Those are the ones. And there was the 3 button ones. Those are the ones that give me all the shite. So let's see. Here's Y1. First, I want to connect 24 volts to. Careful not to short stuff this way. So I should have O turned on. And then I need. I thought I had another jumper out here. So this is going to be Y1. Just to test out my deal. Oh, solder. That's a real good way to short shit, right? So cooling low. Fan speed went right to 125. Minimum, I think, is 65. Just makes the voltage kind of down just below where the fans stop. And it looks like I'm in the neutral zone for the liquid line temp. So if I raise it just a little bit, am I going the right way? Yep. The fan speed should start increasing. There it goes. I got skipping two values each time. It goes through the little repeats there. And I have somewhere in there, if it gets over 100 and something, it just shoots right up real high. Yeah, 210 there. And it should keep going up. I thought I had the minimum set higher. Oh, maybe not. So test my buttons. Also, on the one that's out there, maybe I'll show it to you guys that's out in the unit now. That particular board has not these type with some insulators, but it's all metal. So it was wigging out when I tried to push the buttons on that division. So we're going to go adjustments. Yep. Fan max is 210. So I will crank that up, say like that. And you can save it. Yep. And then it should keep going higher than 210 now. Tell what I just changed it to 220. And it's going to stop there. I thought I changed the default to 240 now. D2. Did I not save this? Oh, I did that in the other version. Make sure I'm on the right one here. So I was changing that to F0 hexadecimal, which should equate to 240. Do my little in-circuit serial programmer there. It just pulled when it connected and recognized the board, just pulled a little reset there. Sees the processor. There it's doing the EEPROM data memory configurations. Just gonna throw in the code. And it's done. So now when it kicks on, it should go all the way up to, what did I say, 240? Hexadecimal F0. FF would be 255. So going from an F down to 0 is 15 values less. So she's creeping up. Pretty cool circuit board. I was worried after I made this. I didn't use optical isolators. I'm just going to use transistors to ground each leg of the 12-volt relays, and or the 5-volt relays actually. So it all runs on the 5 volts of the processor. And I was like, man, that's sketch, because without those optical isolators, you know, sometimes some relays that'll kind of induce the high voltage or switching back across there. I do have like diodes, you know, reverse, you know, polarity diodes, and of course to suppress the coil, you know, we call that voltage, you know, collapse voltage or whatever when you turn off the coil. But yeah, just 240, 241, just the way it works here. I'm going 2, so it stopped there. So that makes the fan run a little faster for a max speed. But I was worried about this, but I think this part's actually been kind of okay. But it kind of run the reversing valve power, which is high voltage. So I might have to change. If I have any issues with just that one later, I could always just change it to a 24-volt coil and rewire it. But I think we're kind of good now. I mean, I'm not getting any issues now. And then, of course, if the liquid line gets below, like, let me turn it way down. Am I turning the right one? There we go. Should start slowing down the fan. So it's kind of how it works. So I think I'm done with that for now. It's 8 o'clock, so it's probably getting dark out there. Well, got the test board here. Ran all day last night. Okay, out here at the Frankenstein twin number 1. Twin number 2 over there, not hooked up yet. So here's the board I just modified last night. Has the capacitors and switches. This is actually one of my boards I had that I didn't have all the components on. So finished it out. Hopefully nothing got forgot. If I'm not mistaken, I need to replace one pull down resistor with a 33K instead of a 10 just to get a little more speed out of the motor, but might be enough left in it. What does this thing have on? Yep, I did change that to 33K. I need to go do that before I swap the board. So back in the laboratory for a second, and we're gonna extract this 10K surface mount resistor and put on this little 33K ohm one. Yeah, use surface mount, they said. As your eyes get old, they said. So this is how we're gonna do it. Okay, between common and the speed signal, say that's good. Well, easily turns into a mess in there, especially in a hurry, and you're hibernating under the umbrella from the inferno of the sun here in Arizona. So board's in, got the reversing valve hooked back up, which is high voltage, going through the relay. It's also when I got a little bit of the shenanigans going on. Uh-oh. It just started a second ago. My power, and look at it. This does not like that high voltage switching across. And what it is, as soon as it starts and goes to cool mode, which once the reverse valve is latched, it's latched. But when it first opens, you're opening a 230 volt, well, it's actually about 250 volts here at my house. Opening a high voltage thing, and it's this, read the voltage, 247 volts there. Yeah, so it's crazy. And opening high voltage across that induces a lot of noise. I didn't use optical isolators, so I should be able to just, hope without getting shocked, just unplug this wire again. So it's active heat for the reverse valve, so I just pulled the wire right there so it's disconnected. Alright, let me put this power in again. It's probably going to be fine. Did the relay click, which would have opened that voltage. It's actually on high now, house warmed up a few degrees, so I think this is gonna be a-okay now. I'm tapping on the board and fucking with it, so fans should have been going already. I gotta see what I left disconnected. Well, looks like I see what's wrong. I gotta reach into the soldering iron, but this little optical isolator, I just tacked them on the bottom, and I got 15 volts on the top of the optical isolator from the 15 volt power coming back from the IPM inverter power module for the fans. And then I had 15 volts at the bottom too, going over to the pull down, or not to the pull down, but I had 0 at the pull down. So it was like I could tell this is pulsing. It was at 240 out of 255, so pulse width modulation is almost 100%. So I had voltage coming across the bottom, but it isn't going over to here and out. So somewhere, I think it just got I just didn't get the solder all the way on there to the pad. I soldered to the bottom, and it should be a through hole, but for some reason, I don't know, it just seems like it didn't connect. But I just kind of wedged my meter down in there, and the fan started running. So I need to go in and get my soldering iron, and I have to do that a little blind here. But I could probably just need to get it down in there and hit that pad right there. Dude, that's stupid. Waiting for my soldering iron to heat up. Just I bent this optical isolator back. You can definitely see that back pad a little bit. So I just need to hit it with the soldering iron. And that's the one that goes through under this resistor, actually, and over here to the speed output. So this cable is my 15 volts from this board to optical isolator, and then signal back, which is mostly like what, 1 to 6 volts, something like that is what usually does most of the range on carrier. IPM's the brushless DC fan motors, both the indoor fans and the outdoor fans. I do believe it's like 1 to 6 volts. But remember, I'll throw up a little chart up on the screen there. So cool thing is this board makes the 15 volts. It's kind of hard to get in there, especially with my old vision now, but I do believe that probably got it. Back in, I don't know. Let's shove this damn power back on. See what happens. Oops. I plug the 5 volts back in on the controller. God dang. Come on, fan. There it goes. Alright. Because it's so warm and the coil is still at 100, which it's probably 100 degrees out here. So that's probably ambient. It's already just going to shoot up. So there goes the fans. Actually just put the other board back in, added the filters, changed the switches so they weren't so metallic-y to my touch. That's kind of a bad idea. Something is odd here. Either I have a defective optical isolator, something. It just wasn't running the fan as fast as the pulse width modulation signal was commanding like I get on this other board. So I might have to throw this one on the scope or something and see what it's doing. But that way it could be reserved for a spare board to get around the units. I don't know. But did that. The update program. Fans moving pretty good amount. So we're on high speed cooling now. So that is 17 amps, 2.6 kilowatts. Power factor was being like crap with all reactors that could be diodes. I'm reaching here and unplug. Hopefully that's screwing anything up. Second stage. Just so I can slow down. Liquid line was at 106. It was saying 99. Oh, I unplugged the wrong thing. It should be on low. I might have to find out and put this back on auto. See what's going on there. Oh, my eyes are turning to shite. I see what I did wrong. I put these 3 wires, 24 volts, low and high. Got them backwards in there. Got the 24 volts on the second speed output, And then I had the 6-speed output on the common, it looks like. Goodness, let me try this again. Alright, Y2 input still unplugged. There we go. That should be on 40 hertz. And it's going to start up. Fans are going already. Oh no. So really interrupted by the piece of shit Goodman. Damn that thing. Alright, so we'll let that go for a while. See how she runs. I just switched it between low and high a couple times and all switched okay. Controller seems to be working. Fans ripping. Liquid line's 104. Outside air is 95. I mean, it's pretty good approach temperature right there. Can't hear shit over the frickin' Goodman unit. As I said, I wanted to get Frankenstein Twin number 2 in there, but given that I'm still kind of tweaking with this and summer already kind of got here, it's doomed to stay for the summer at least. I'll go mess around with that other board. And that's it. Don't forget to like, share, subscribe, and comment. Catch you guys all later.